A rational function is in the form of a function over a function, where p of x and g of x are polynomial expressions, and the domain of the rational consists of all x's for which you cannot have the denominator equal to 0, because that's a big no-no, right? Okay, so do you remember how to graph y equals 1 over x? Okay, so if you don't, what we did in grade 11 pre-cal is we drew what we knew, and then we made the function into what it needs to be. So for instance, I know how to graph f of x equals x. That part of the function. Does everybody understand? How do you graph that? It's just one of those 45 lines, yeah. So 0, 1, 2, 3, like that. So then I'm just going to connect the dots here. Yes? Okay, so this is my f of x equals x line. So then what we did in grade 11 is we made it fit what we needed to graph here, which is 1 over x. So recall from 30S pre-cal, given f of x, the reciprocal is 1 over f of x, where f of x can't be 0. To sketch 1 over f of x, we determine all the reciprocals of all the, what is f of x a fancy name for again? Y. And before I go on, this is still a misconception a lot of people have. They think that 1 over f of x, which is the reciprocal function, is the same thing as moving it to the top and making an exponent, and that's the inverse function. They are not the same thing. If I wanted to move this to the top, it would become f of x to the power negative 1 like that, which is not what that is. This is the inverse. This is the reciprocal. Yes? Okay, so the original function x-intercepts become, so what happens? If I take 0, that's the height. Remember, y values are the height. If I look at the height, and the height is 0, and I reciprocate it, now I have 1 over 0. Can't have that. So what does that represent graphically? An asymptote. Yes. So now all the x-intercepts, because that's where the height of y is 0, become vertical asymptotes. Okay? So what would be an invariant point here? Yes, so any value that's a height of 1 or a height of negative 1 will stay the same. So that's the next step I always say in our graphing. Find your ones, because those are your invariant points. Yes? Okay. Where f of x is positive, what happens when we flip a positive f of x? It still is positive. It doesn't change sign. And where f of x is negative and we flip it, it's still going to be negative. Does everybody get all those concepts so far? Now here's the huge thing, and this leads us into the concepts of calculus actually, is large y values. If you think of the largest y value you can think of besides, and infinity is not a value, it's a concept. So let's just say 1 million, right? And we reciprocate 1 million, so we get 1 over a million. It's like the smallest number you know, right? So between this 0 and 1, we have really small numbers. So what happens when we reciprocate really small numbers? It becomes really big numbers. And because these are positive small numbers, we reciprocate it, it's going to become big positives, yes? So that's where it goes this way. Now here, do you see this is getting bigger and bigger positives? If we reciprocate it, it's going to become smaller and smaller. And what's the smallest that it could be without crossing into the negatives? Very, very, very close to 0. So that's where this part of the graph goes like that. Okay, so I'll repeat. Between 0 and 1 are very small y values. I reciprocate very small y values. They become very big. So think about 1 over a million. If you flip that, that becomes a million. Or if I go the other way, all these big numbers, I start at a million and I flip it, I'll get 1 over a million, which is really small. Okay? Same thing over here. If I have really big negatives and I reciprocate it, they become really small negatives. And these small ones between 0 and 1, when I flip it, they become really big ones. Do you see that? And then because we can go as close to 0 as possible, we're going to have to indicate that at the far left, we have a horizontal asymptote, and at the far right, we have a horizontal asymptote. Remember that horizontal asymptotes don't necessarily go through the whole entire graph. This is just end behaviors. It's approaching 0 at the far left, and it's approaching 0 at the far right. In calculus, we say what it's called the limit as x goes to negative infinity. The limit that x goes to negative infinity of f of, I guess it's 1 over f of x that we're talking about. So as far left as you can go to the left, what do you think that it approaches? 0. Same over here. This would be in calculus the limit as x goes to positive infinity of 1 over f of x. So what that means is as far right as you can go, what would the height be? It would be 0 as well. So just a little enrichment there. Okay, so large values of f of x become very small, and very small y values become very large. So this is something we already know. So today's lesson is all about doing transformations of this, okay? So all the transformations will be in the form y equals a over x minus h plus k. So are the locations of the asymptote affected if a vertical stretch of a is applied? No. Does everybody understand? X is 0, vertical is not going to affect it. Right? Can you tell? So that means that the vertical asymptote will always be at x equals 0 unless what happens? We shift left or right. Okay, so can you tell from the, also I guess horizontal, right? If you think about that way, a vertical stretch wouldn't affect it either. The only way that would get affected is if we go up or down. Can you tell from the equation of the transformed rational function y equals a over x minus h plus k where its graph has a vertical asymptote? A horizontal? So what would the vertical asymptote, I'm going to abbreviate from now on VA. Where would the vertical asymptote? Now usually it's at x equals 0 like we just saw. Which one would affect it? We just finished saying the vertical asymptote would only get affected if it went left or right. So it would be h. So h would move it left or right. Does that make sense to you? It's not any different than our first unit, right? So that means whatever that number is, so for instance, I'll give you an example. If it was y equals 1 over x minus 2, where did that vertical asymptote go? Right to, what's my new vertical asymptote? X equals 2. So that means my vertical asymptote is x equals whatever my h is. Do you see that? Okay, what about my horizontal asymptote? My horizontal asymptote is this way. Yes, k would get affected. So if I give you an example, something like this, y equals 1 over x plus 2, that means the horizontal shift got shifted up 2. So again, instead of y equals 0, it would be y equals k. Describe how the values of a function of x approaches a non-permissible value. So the non-permissible value, if we look back up here, is where we have this vertical asymptote. X cannot be 0. So this is now the calculus approach to it. The closer and closer and closer from the right, do you see I'm coming from the right? That we get to this non-permissible value 0, what happens? it goes to infinity. So how would I write that? The limit as x goes to 0 from the right. That's what this means. This is now calculus stuff we're talking about. This is exciting, hey? Coming from the right, as we approach that non-permissible value of 1 over f of x, what happens? It goes to infinity. So you'll see in the textbook they try to use non-calculus terms. They'll just say as x approaches 0 from the right, y goes to infinity. That's how they write it. Okay? This basically means the same thing. Okay, so now let's look at it coming from the left. When it's coming from the left, what happens? It's coming from the left and it's approaching x equals 0. It goes to negative infinity. So how would I write that? The limit as x goes to 0 from the left of 1 over f of x, we get negative infinity. And how the book writes it would be x approaches 0 from the left, y goes to negative infinity. Okay, so here is our new graphs we're going to do. 1 over x minus 2 plus 4. So can anybody tell me what the horizontal asymptote would be? So we don't just say 4, we say y equals 4. And what would so we're going to draw that at 4, and I'm going to actually do it across just to get, I know I said you don't need to, you don't need to, but I'm going to do it across because we don't know where our floop is going to be, right? My floop is a high technical term, floop. Vertical asymptote, where is it? X equals 2, and we know that because it usually is at x equals 0 and it got shifted to the right. So x equals 2. Okay, do we have any vertical stretches? No. Do we have any horizontal stretches? No. So then the base graph will be exactly the same, the 1, 1, and a floop. That's all you need to know. You know what I mean? The 1, the floop. Now make sure you don't curl away from the asymptotes. The arrows can hit the asymptotes, the line of the graph or the curve cannot. So my arrowheads can hit the asymptotes, it's just the line can't, okay? And you can't curl away. So, is everybody good with how I graph that? I use the base graph. Remember the base graph was this graph right here? And the only 2 points I had on that base graph was the 1 and the negative 1, those invariant points, and then it was just a fluke. So, I already shifted it. I shifted that floop. If you imagine that floop here, it shifted right to up 4. There's the new floop. It's already done. What's the x-intercept? So how would I solve the x-intercept? Set y to 0. So 0 equals 1 over x minus 2 plus 4. Move the 4 over. I get negative 4 equals 1 over x minus 2. Here's another example where cross multiplying better be your friend. Cross multiply it over. Negative 4x plus 2 equals 1. Negative 4x equals negative 1x equals a quarter. Oh my gosh, it's plus 8. I was going to say that didn't seem like it was right. Negative 9, negative, so then it's 9 over 4, which makes sense then, because I was going to say it's going at, that's horrible. Move the 8 is negative 7, so then I get 7 over 4. 1 3/4 is exactly what it shows. See, we knew we made a mistake because it didn't make sense on the graph what it looked like. So make sure whatever you do algebraically matches your graph, right? So 7 over 4. What's my y-intercept? You should be able to do mental math, but just in case you can't, y equals 1 over negative 2 plus 4. What's 4 subtract a half? 3.5. What's 3.5 as an improper fraction? 7 over 2. 7 over 2 is approximately 3.5. So yes, it's crossing there. It's crossing there just like we thought, right? Okay, what's my domain? Domain. Negative infinity to 2 and 2 to infinity. We don't include 2. It goes all the way up to 2 and then it starts again at 2. What's my range? Negative infinity to 4. Again, it doesn't include 4 at any point in the graph. Yes? Okay. Next one. What happened here? It got shifted to the right 3 and up 4. But there's something that happened before that. There's a reflection over the x-axis. Okay, it's affecting the y's, right? Okay, so what's my horizontal asymptote going to be? Y equals 4. So we're going to do that again. What's my vertical asymptote? X equals 3. Okay, so normally my base graph, I would have the ones like this. Right? Right there. But what happens if I reflect it? It's going to be on the other side. It's going to be over here now. So put a point there, a point there. We have a floop. We have another floop. Bada bing, bada boom, it's done as fast as that. What's my x-intercept here? Well, let's figure it out. It looks like it's about 3 point something, so it better be that when I solve it this time. 0 equals negative 1 over x minus 3 plus 4. Move the 4 over. Negative 4 equals negative 1 over x minus 3. Does everybody understand this negative 1? Associate it with either the top or the bottom, but not both, right? Because if it was both, then what would it really be? A positive. So now I'm going to cross multiply that over, and this time I'm going to do it right. Negative 4x plus 12 equals negative 1. Everybody good with that? Move the 12 over. Negative 4x equals negative 13. X equals 13 over 4. How many times does 4 go into 13? 3 1/4. Look at that. We did it right. Okay, my y-intercept looks like about 4 and a little bit, right? Well, let's see. F of x equals negative 1 over negative 3 plus 4. Does everybody see how I got negative 1 over negative 3? Y-intercept. Negative over negative makes a positive. So basically I have 4 1/3. What's 4 1/3 as an improper fraction? 13 over 3. Yes? What's the domain? Negative infinity up to 3. 3 to infinity. What's my range? Negative infinity up to 4. 4 to infinity. Everybody good? Okay. Ooh. I give lots of space for this. I wonder why. Because we have a strange one. It's not in the form y equals a over x minus h plus k. So we have to do what? Factor. There's nothing that you can factor out of there. What are you talking about? Are you going to do some things that you shouldn't be doing here? Long division. How many times does x minus 1 go into 2x minus 1? Well, how many times does x go into 2x? 2. Now we go 2 times x is 2x. 2 times minus 1 is minus 2. What's the next step? Switch the signs. I'm going to do a different color. So that means the 2x's cancel. And what do I get here? 1. So what does the 1 represent? The remainder. So this is 1 over
1 over x minus 1.
So let's rewrite this. This is 1 over x minus 1 plus 2. Hey, that looks a lot better. Do you see how everything's all coming together now? All the stuff you learned from before. What's my horizontal asymptote?
Wait, shouldn't it be x minus
Wait,
1?
I moved it right there.
Oh, yeah, minus 1.
Oh, I'm just making mistakes left and right today. What's going on with me? Okay, what's my horizontal asymptote here?
Y.
Y equals 2. Let's draw it. Y equals 2. What's my vertical? X equals 1. Let's draw her in. Do we have anything we got to worry about, like stretches, reflections? No, then we just have a 1, 1 floop. Isn't that the quickest graph you've ever graphed before?
Really?
What's my x-intercept? Oh, it's about point something. I did. So if I want to find my x-intercept, it's up to you if you want to use the divided form or the original form. Which one do you want to use, the original or the divided? Okay, what's my x-intercept? 0 equals 2x minus 1 over x minus 1. I'm going to cross multiply. What happens when I cross multiply? I get 0 equals 2x minus 1. So what does x equal? 1/2. Does that look like 1/2? Yeah. Ish. Okay, so my x-intercept's 1/2. My y-intercept. What do I get there? That's an easy one. I could just do mental math here. These go to 0. -1 divided by -1 is 1. Okay, how do we graph this? Ooh. We need to graph what we know, which is a parabola. Let's graph it. And if you don't know how to graph a parabola by now, I'm a little worried for you. Zero, zero, 1, 1, 2, 4, 3, 9. Go, do it. Now, we need to reciprocate all the y values. So what happens? Anything of a y value that's an x-intercept become an asymptote. And I'm going to label these because if you have more than one graph on your graph, you need to make sure you say which one's which. Okay? Otherwise, we're marking the entire graph. Well, f of x is already established as 1 over x. So I'd have to either use g of x or I'm using y at this point. Does everybody see that I'm going to have a vertical asymptote at x equals 0 and why that's the case? Well, it's because it's the x-intercept versus the y-intercept. Because where x is 0, sorry, where there's an x-intercept, y is 0, and when I flip 0, I get undefined. Okay, so now I have a 1, 1. We're not doing a shift thing here because this is not in the form. I can't make it in the form. This is just some function that I'm going to build it to make it, right? So right now I graphed y equals x squared. Now I'm going to graph 1 over y, right? And that will be what I need. So does everybody see my invariant points are 1s? Smaller becomes bigger. Bigger becomes smaller. Between 0 and 1, that smaller becomes bigger. Bigger becomes smaller. So then I have a horizontal asymptote at each of the ends. Does everybody see that? Okay, let's graph the other one. How do I graph this parabola? This is a parabola that got shifted down 1. So there's my 0, 0, 1, 1, 2, 4, 1, 2, 3, 4. And if you want 3, 9, but I'm not even going to go there because I really don't care. Well, just because I'm not going to reciprocate 9 there. Does everybody see what I just did there? So where's my asymptotes going to be then? Remember, it's wherever you have x-intercepts. That's where y is 0. And we reciprocate it, we get undefined. So we're going to have 2. Right there. And you guys have seen this. Yes? Where's my invariant points? At the 1s. I have 1 here. I have 1 here, and I have 1 here. Find your 1s. Sometimes the 1s are not in an actual nice whole number spot. They're in between. You just got to find the heights of 1s, the heights of negative 1s. Where the x-intercepts is, 1 and negative 1 there, right? Okay, so same technique. Between 0 and 1 there, that's small. We reciprocate it, we get big. Yes? Bigger becomes smaller. Same with this one here. Bigger becomes smaller. Smaller becomes bigger. Oops, I'm a little curving away there. And I actually went past my asymptote. I need to fix this one because I would lose error code. No, you're going to have an asymptote right here. The question is, shouldn't my asymptote be lower than y equals 0? And my question to you would be, why? It's going, does everybody see? It's only going as close as 0, right? It's not going to go into the negatives. How can a positive, when you flip it, become a negative? Does that make sense to you? Okay, so now, remember, so when you flip things, they can't cross into the negative zone if they're a positive to start with. So what happens here? All we have is, it's at negative 1 and it's really small. So what happens when we flip small negatives? It's going to go big negative. Remember a graph that looked like that? Yeah. What's the non-permissible values? X cannot equal 0. Over here, it's x cannot equal plus or minus 1. What's the behavior near the non-permissibles? So let's write it the calculus way. And that would be the limit as x goes to 0 from the right. I'm coming from the right. And when I hit that non-permissible, what happens? It goes up. So what is that? Yes, so this is actually, so from the right of f of x is infinity. What happens if I come from the left and I hit? They're both infinity this time. What happens when we hit over here, the non-permissible from the right? What happens? It goes to infinity. What happens when it goes to the left from that? Now, here's the thing about the left. You can't come this far because you're going to hit the first non-permissible. So you can only come from the left between this non-permissibles, right? Or correct? So what's happening here when I'm getting close to the 1 on the right? It actually goes down to a negative infinity. Does everybody see that? It's going down. So now we actually have another non-permissible we got to worry about. That is negative 1. So let's come from the right from negative 1. Here's negative 1. We're coming from the right. What's going to happen? It goes to negative infinity. What happens when it comes, it goes to negative 1 from the left? It's going to hit negative 1. What's going to happen? It goes to infinity. So now, what's the end behavior? The end behavior is the far left and the far right. So what's happening at the far left? And again, in calculus terms, this would be the limit. Oops, I have a thick pen. The limit as x goes to negative infinity, that would be the far left. Negative infinity. What happens? What's the height? It's 0. It gets as close to 0 as possible, so it's 0, yep. And If I go to the far right, so I'm going to travel this way to the far right, where am I going to end up? Basically 0. What's going to happen here? Far right, 0. Far left, it's going to be the same for both, right? I'll just say same. Okay, what's the domain? The domain. Negative infinity up to 0, and then 0 to infinity. What's the domain here? Negative infinity up to -1, and it's a round bracket because it doesn't include that. Then we have a little section of -1 to 1. Everybody see that? Then we have another section from 1 to infinity. Does everybody see that? Okay, my range. What's my range here? Starts at what? 0, so not including 0. And then it goes to infinity. Okay, this one's a special one on the right. So I'm going to scroll up to the graph so you can see it. Look at the range. We're going from negative infinity, and then what happens? I hit -1, and then there's like nothing, right? And then where do I start up again? At 0, but not including 0, and then I go up to infinity. So does everybody see that? So it's going to be negative infinity to -1, including -1, so I have a square bracket. Then it's going to be 0 to infinity. We're going to get even more complicated graphs where you're going to have all these asymptotes, but sometimes the range might be everything just because some parts of the graph fills in the rest. Like, do you remember from grade 11 we had a graph that kind of went like this through it, or no?